The CLI and C-cube casting processes can be combined in order to efficiently cast thick-section parts using reactive alloys. The mold and ceramic snout are preheated to 2,000 degrees Fahrenheit. The snout and, for this application, a spacer are positioned inside a vacuum chamber at the loading station. Using robotic assistance, a hot mold is positioned over the fill pipe. A seal kit is used at the junction of the mold and fill pipe, and a cap is placed atop the mold central riser. The casting machine robot raises the chamber to the sand fill station. This media serves to rigidly fix the location of the mold within the chamber, as well as to contain any molten metal that may issue from imperfections in the mold. The chamber is lowered, moved away from the fill station, and the vacuum head is closed tightly on top of the support media. The chamber is sealed using an inflatable tube. A fine mesh screen inside the vacuum head is permeable to gas, but does not permit the passage of sand into the vacuum-controlled network. The mold package is transported to the casting station. For this application, a CLI casting unit which blankets the molten metal with an inert gas is being used. The fill pipe is first lowered into the inert atmosphere. A partial vacuum is momentarily applied to the chamber, eliminating air within the mold and replacing it with inert gas. The chamber is further lowered until the snout is submerged a precise distance into the melt. When the chamber is again partially evacuated, the inert gas, which blankets the melt at atmospheric pressure, causes metal to flow upward into the mold, completely filling the part cavities. In the C-cube process, which is used for both air melt and CLI casting, rotation is applied to the casting chamber. Once the desired RPM is reached, the liquid metal is held in the gates by centrifugal force, and the vacuum can be released. After the central sprue is emptied, the centrifugal force continues to apply uniform feeding pressure to each casting until solidification is completed. Unlike other casting processes, the feeding conditions at all elevations in the mold, top to bottom, are identical, and this assures a higher level of consistency in part quality. When all metal has solidified, the rotation is stopped, and the chamber is moved to a discharge station. The vacuum head is opened and the chamber is rotated, depositing the cast mold and support media into a bin. Combining CLI and C-cubed enable the economic production of reactive metal components that combine thin walls and thick sections. Such parts are difficult to produce using gravity-poured vacuum casting technologies.